Hello everyone, welcome back to Bitwig Studio and Music Production. This is lesson number 7, and in this lesson we're going to be talking about sampling rates, bit depth, and different types of audio file compression, specifically digital audio file compression. So you've already probably been sufficiently freaked out by my bizarre tangents in the last lesson looking at things like film versus digital video. But now let's jump back to reality, and we're going to be focusing specifically on digital audio in this lesson, and hopefully for the majority of the lessons moving forward, unless I'm inspired again to go on a crazy hunt on YouTube and pull up super bizarre clips. Anyway, I've kind of already set this up for us to make it go a little quicker, but basically what I've done here in Bitwig is I've gone to my preferences, which you can get to by going to Option Preferences, or you can select Command comma if you're on a Mac. If you're on a PC, I assume it's like Control comma. I don't know. I haven't used a PC in a really, really long time. But anyway, I'm going to select Command comma because it's always good to use your key commands when you can. Just important to learn. And what I've done is I've adjusted the sample rate, which by default is going to be at 48K. or 48,000 hertz, and I've bumped it up to this 176400 hertz. I'm actually not sure what that number even is. This is a bizarrely high number, 176.4 thousand hertz. All right, and what I've done is I've recorded in my voice here, and that's going to be the sample we're going to be looking at. So I'll just let you guys hear it once really quickly so you know what it is we're dealing with. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. So for some reason I decided to get a little jingly there. Please don't hold that against me. So Brittany, if you're listening, don't hold that against me. And so what we're going to do now is I'm going to show you guys a way to convert your files before we even start talking about sampling rate and bit depth. I've already done it here, but I'm going to show you guys a nice free tool and resource you can use. That tool is let's see if I can find the right thing. That tool is the Media Human Audio Converter, which you can find by going to this link, or you can just search Media Human Audio Converter. I'll also put it in the description for the video. And this is a nice tool. It's available on both Windows and Mac, as you can see. And what it will do is it will take your files and convert them to either lossless or lossy file formats. For now, we want to stick with a Wav file. And the Wav file is the most basic pulse code modulation audio file. In essence, what we're doing is recording into our computer, and this is the highest possible quality file that can come out. The higher your sampling rate value, the higher the file size, but also perceptually the higher the quality of the sound you're going to get. However, it does vary on bit depth, but we'll talk about that later. So for now, just realize that the higher the number, the higher the quality, at least in theory. So I have these spread out here. If you're using Media Human, what you would do is you would take your file and you could drag and drop it in here as such. And then if you click to the left on this box, you're going to have the option to change between all these different file types. And then in here, you can choose the bit depths. I'm not sure if you can actually change this to mono. Let's see. Oh, I actually can. So I'm going to redo this because I bounced all of these to stereo like a moron, and so it's not really going to be as good a representation if I bounce them all to mono, because this main file is actually a mono file that we had coming out. So that was good to learn. So I'm going to bounce these. Oh, sorry, I have to do this. I'm going to have to go multiple ways. Jeez. Mono, and let's go with 48 for right now. Click OK. Make the conversion. It's done. I'm going to drag it in again. We're going to do a couple other ones. Again, Wav. Let's go to custom. Again, I'm going to go mono. And I'll do 44.1. 44.1 is standard sampling rate for CD quality audio. But for right now, don't worry about why the number is 44.1. We're going to talk about that in a later lesson. So I'll make that conversion. I'm going to drag it in again. And this time I'm going to select the lowest I possibly can. Custom once again. We'll go to mono. Sample rate will go down to 8,000 hertz. And I'm going to close this up and I'm going to make the conversion. One other thing about Bitwig Studio that's super handy that I should have showed you guys is that when you record into Bitwig, one thing you can do to access your file really easily is go into the browser tab here, which you can either do by clicking this button or just hitting the B key command. So let's go away and I'm going to select B. And there's my browser. If I navigate over to browser and then files, what I can do is I can go into my current project and I can actually grab the recordings that I've made for that project right here. And the great thing about this is you're going to get a little dialog box with some of the information. So you can see that we've sampled this out at 176.4K and we're in mono and it's a 24-bit depth. And the other great thing is that I can just right click this guy and I can copy it. And then I have the ability to paste it to the desktop really, really easily, which is awesome. Using some other digital audio workstations, that can be a bit of a pain. So I just wanted to show you guys the ease with which you can take files that you've just recorded in and pull them out to other places on your hard drive if it makes it easier for you to do that. So let's go ahead now. I don't need these guys because I screwed up. I'm going to open up a Finder window. I'm going to go into my documents, or actually into my music, go to Converted by Media Human, and here are my files. So when I click this up, it's actually going to give me the sampling rate. So I'm going to rename these quickly. Let's just call this one 48K. Let's call this guy 44.1K. And then our other dude should be 8,000K. So I'll just call it 8K, which if you know anything about digital projection, you know that 8K is incredibly high quality. But with audio, it's, in this particular example, going to be the lowest quality sample rate we have. So the next thing I want to do to explain to you guys what's going on with sample rates is look at them in a different audio application, and that application is called Audacity. The only reason I'm using Audacity and not Bitwig is because in Audacity, I'm going to have the ability to zoom in so close on these files that we can actually see the points at which they're being sampled. And so that's going to make sampling rate make perfect sense to you guys, where just trying to explain it in words can oftentimes be a little bit confusing. So let's see. Audacity is available for free. It's open source. It's on Mac, Windows, as well as on Linux, and it's a really great program. It comes with a bunch of plugins. Right now, if you guys are new to audio production, into digital audio, you're not going to know how to use any of those plugins, but hopefully when we finish our whole course and working in Bitwig, you guys will know how to use all those things, even if the interface isn't exactly ideal. So I'm going to open up Audacity. Let's create a new project. And I'm going to drag and drop all of these files into Audacity. It's going to ask me if I want to make a copy of these, and I'll just say OK for the time being. And so now I have my 4 files in here. And let's see, these aren't perfectly organized in terms of quality. And by looking at these files right now, you're going to say, these look almost completely identical. And if we were to listen to them, let's actually just go ahead and listen to these files, and you tell me in the comments if you hear a difference between any of these guys. So here's our one at 176.4 K. All right, so 176,400 hertz. Let's listen to the first one. This is what is going to be perceptually known as the highest quality file we've got. Let's click play. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Now, don't be alarmed by the fact that the quality just doesn't sound great because I am recording through the internal microphone. That's not what it's about. It's about quality of this signal. So we're using this as our base. We're using this top file as the base for everything else we listen to. Let's play it one more time without me constantly blabbering. And I'm just going to go through all of these. And again, let me know if you guys are able to hear any kind of difference. Testing, testing, 1, 2, 3. 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 And let's just do one quick comparison from the top to the bottom. Testing, testing, 1, 2, 3. 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 Now, if you can't hear any difference between these first three, that's totally okay. The truth is, I can't really even hear a difference between these three, and there's a reason why I can't hear a difference between them, which we'll talk about in a later video, so you'll just have to stay in tune for that, especially if you're a total audio geek like me. You're going to look forward to hearing the reason for it. But for now, I'm going to explain what sampling rate is in as layman-y terms as possible. Basically, your sampling rate, this number is indicating the number of points that are going to be plotted on the x-axis, which is time, over a 1 second duration. So for this case, we have 1 to 2. And what this sample rate is indicating to us is that 176.4 thousand samples have been taken between these points, 1 and 2. Okay, 1 second to 2 second. Likewise here, 48K, so 48,000 samples have been taken between this 1 and 2. And where they're taken across is simply the time axis. We'll talk about bit depth, which is basically going to indicate the choice it has for how high or low the point is going to be on the y-axis. So 44.1, again, 44,100. And then the last one here, 8K. And you can even see that the audio file looks different. You see that there's a little bit more clarity in this guy up here as compared to this bottom one down here. All right, let's take a look now. Let's zoom in and see exactly what's going on if we can make this point any clearer. So I'm going to have to zoom in all the way. Right now, they still look fairly similar, which makes a lot of sense. I'm going to zoom in even closer, 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 and eventually you're going to start seeing dots appear. Okay, these dots are the actual individual sampling points along this audio file. So this is pretty crazy. So as we get closer, what you're going to notice, and what I'll probably do is close up this 48K, or actually let's just move this up. Let's move up. Let's talk about the starkest differences. The huge one right here that is sampling 176.4 thousand times per second versus the one that's only sampling 8,000 times per second. So let's move this one up. And then we can make these guys just a little bit bigger. And let's actually just zoom over a little bit. It's very fascinating. There are actually points along this 8K where you can't even really see the lines, which is kind of interesting. But what you're going to obviously notice here is that there's a lot more dots, and therefore there's the ability for this to be curved a lot more than the 8K version is. And so the 8K, you can literally see straight lines going through this file. Okay, so this file, there's going to be a lot more detail and a lot more what we would call perceived quality to the sound, at least from the source, from what we've recorded into our medium there, and to what you're actually hearing. This is very, very fascinating stuff right now that we're going over. All right, so once again, let's just zoom out so you can see the difference in the file. Look how these are basically straight lines. As we go back, it's going to become a little bit more curved. You can still see the dots here. And as we go farther out, the files are going to look quite similar, but obviously from what we've just shown, they're going to sound very, very different. So we'll listen to the first one again. Testing, 1, 2. Let's not loop it. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. And now this 8K. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. And if you're thinking, wow, that 8K one sounds like a telephone, you would be right. And there's a reason why when you talk to somebody on the telephone, their voice doesn't come out as clearly as it does when you actually record into your computer or you record into a microphone. But we'll be covering that a little later on. So the other thing we're going to talk about here is bit depth. Okay, and bit depth is basically a binary function. Again, it's all ones and zeros. And bit depth is going to be where these sampling rates, let's go back over to this, well, we can talk about the 8K one as an example. Come on. The bit depth is going to determine the number of choices that each sample rate can take up on the y-axis, so on the amplitude scale. It's referred to as quantizing, I believe. I'm not 100% sure why it's called that, but basically for our purposes, we're going to think about sampling rate as the number of points over time and the bit depth as the relative amplitude. So I'm going to show you guys real quick the audio bit depth here, the Wikipedia page. And so this is going to explain to you guys exactly how many choices that you have based on the number of bits. So if it's a 4-bit audio signal, you're only going to have 16 possible amplitude values. If you have a 1-bit audio signal, you're going to have 2 choices, right? 1 and 0. And so the application of something that's 1 bit, and we'll talk about this with MIDI, is virtually you can only really use that for one thing, and that's on or off. So let's say 1 is indicative of on and 0 is indicative of off. If we had a 1-bit audio file, it would only be either full amplitude or no amplitude. And so that's not going to be very useful to us if we want to get something that sounds very clear. Here you can see 8-bit 256 values. Where we start getting into, I would say, something that's going to sound a little bit more natural is 16-bit. 16-bit is CD quality, and with 16-bit you have 65,536 possible amplitude choices from the lowest choice up to the highest choice. And this is showing it to you guys with the base 10 signed range. So from negative 32,768 to positive 32,767 from your lowest to your highest point here. Obviously, since 0 is going to count as one of those values, that's why you're going to see this as an 8 and this as a 7. Also, audio is known to be oftentimes recorded with 24-bit depth, and just look at the difference here in your amplitude values from 65,000 to almost 17 million, or I guess we'll round up here, from 66,000 to almost 17 million. So most of you are probably thinking right now, why isn't everybody recording with 24-bit depth and a super high sampling rate? Well, the downside to a very high bit depth and a very high sampling rate is that the size of your audio file is going to increase exponentially. You remember how we talked about these files all being ones and zeros? When you are sampling at a very high sampling rate and you have a very high bit depth, that is going to be more ones and zeros than sampling at a lower rate and using a lower bit depth. If you guys have any more questions about that, please feel free to ask me. The next topic I want to cover is other types of file compression and different file types. Right now, I'm only going to talk about the file types that are very common in digital audio today. The first one we're going to talk about is a form of lossless compression. And let me just get ourselves all situated with a new Audacity file at the moment. And lossless file types are designed to decrease the size of the file but maintain the same sampling rate and the same bit depth. So in essence, you're going to have the exact same file, just a lower file size. And the one that's very popular today is the FLAC. And I'm going to go ahead and make that conversion here in Media Human. Let's go to FLAC. Oh, did I bring in the wrong file? No, this is the right one. I apologize. And let's make this mono. And let's take the sampling rate to 48. Okay. And let's make the conversion here. All right, we got to go back and find it again. So it's going to be in music, converted by Media Human. Hopefully there's nothing too embarrassing in my audio file right now. And I'll pull this out. And again, this was at 48K. So let's compare these file sizes briefly. So this 48K WAV file is 528 bits. We'll compare that to this FLAC file, which is actually around 500 kilobytes. But if you imagine a very, very long file, so something that's like 3 or 4 minutes in length, this is going to add up a lot more. Even if you look at the percentage here, it's a pretty big difference from 528 to 499. Unfortunately, it's not as mind-blowing or revolutionary as if you were to use a full song, but you could see why people would want to use this file format because it's going to make that relative size a lot smaller. And the thing about FLAC files is that they will take up a little bit more of your CPU usage. So it takes a little bit more power from the computer to play back an FLAC file as compared to a WAV file. Another advantage of an FLAC file is that you can actually import tags. So you can put a lot of metadata into these files. And what I want to show you guys is in Audacity what these two are going to look like side by side. So let's see, do I have my blank one? Here it is. Let's pull these two guys in. Nowadays, most media players have the ability to play back a variety of different file types. All right, so what we have here is our WAV file here, followed by our FLAC file. And the thing you're going to notice, and the thing that audiophiles will go a little bit crazy about, is that FLAC files are going to be slightly lower in overall perceived loudness. And the reason for that is because FLAC files actually require some of this space at the very top for tags. So to write in the artist name, to write in the album, all those things. So it actually takes a little bit of space. It takes physical space on this spectrum to do that. So if we zoom in here a little bit closer, you'll see that this one is peaking out just a little bit higher. But if we zoom in all the way here like we did before, you'll notice that these dots are lining up exactly, and that's because they're both using the exact same sampling rate and the exact same bit depth. So if we listen to these two files back to back, you are probably not going to be able to hear a difference. Some people will claim that they can hear a difference, and maybe some people can, but personally, I'm not one of those people who can hear that difference. But let's go ahead and play this through. 1, 2, 3, testing, test. Sorry. Testing, testing, 1, 2, 3, testing, testing, 1, 2, 3. By the end of this, you're going to want to kill me. Now let's play the FLAC file. Testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. Yeah, I can't hear a difference. Maybe you guys can if you're in some kind of multi-million-dollar recording studio with a crazy, clear and pristine setup. But again, if you want to go more into the differences between WAV files and FLAC files, you can easily do that by just like Googling those two terms, and you'll get to read through tons of forums of people arguing about whether there's too much of a difference or not. Personally, it's not something that worries me too much. It doesn't keep me up late at night, but it seems to keep some people up late at night, so it might be worth looking into. The other type of compression is referred to as lossy compression. Lossy compression just means that we're actually going to be losing parts of the WAV file itself. And so with MP3, which is of course the most popular lossy file type there is, I don't have this up, of course, like an idiot, but we can get it up very quickly. It's going to explain this a little bit better than I probably can. Basically, the compression works by reducing accuracy of certain parts of sound that are considered to be beyond the auditory resolution ability of most people. And that is very true. If you use a higher KB, kilobit per second compression rate, if you use something like 320, the difference between that and the WAV file, I can actually hear that difference, but it's not going to be something super major to most people. The majority of consumers listening to music on their iPod, like if they have a CD and they're listening to the latest Beyonce track or whatever, and then they put on their iPod and it's the MP3 version, most people aren't going to notice that much of a difference, to be honest. So let's go ahead here, and we're going to do a little bit of an experiment yet again. Let's use the 48K version as our example. And now we're going to be converting to MP3. So again, we can go in here and select MP3. The majority of these file types are actually lossy compression. So a lot of these, they're actually parts of the audio file are being taken out. That's not going to be audible to most people. But we'll use MP3 because that's the real common one here. And let's go to custom yet again. And oh my gosh, can I actually select bit rates? That's pretty cool. I'm going to select mono for channels. Sample rate, I want to be at 48. Bitrate mode, I have no idea what these two mean. I'm going to leave it at CBR. And I'm going to start with a 320. Click OK. And let's make that conversion. And now let's do a couple more just for the sake of example. And let's do 128 now. And one more again. We're going to do the lowest one possible to us. Down to 64. That's going to make quite a big difference. And we will click 48 for sampling rate. We'll click OK. And we'll make the conversion. All right, let's pull these guys up again. So this one is not telling me the bits per sample. Real helpful, guys. Not going to help me, but I should be able to remember. So the second one here, this was the lowest one. This was 48 by 64. This was the first one, so this should be 48 by 320. And this last one here should be 48 by, what was it, 128, something like that? Close enough. And now let's go ahead and load these guys into a new Audacity file and take a look at the WAV files and listen to what we actually hear. So is it going to open up a new one for me? How am I going to have to do this? Thanks a lot, Audacity. You're really being a pain here. Anyway, I'm just going to go back in here. I'll just delete all these channels and we can do it manually. Hopefully I remembered to mono all these guys out. I did. Okay, cool. So let's try to sort these in order by what would be the highest quality by the lowest. This right here is our WAV file. So we'll move this track up. It's probably a much quicker way to do it, but I'm sure you guys really enjoy watching me move these things up and down. It's quite a bit of fun. The next one is going to be 320. 128.64. Cool. So the first thing you're going to notice is that these are not lining up exactly. So my start of my waveform with my WAV file is about here, and the start with these MP3s is a little bit further ahead. I actually don't know what the reason for that is. I can probably look it up pretty quickly if I wanted to. It might be just part of the media human system, and my guess would be that to do this type of compression, the coding and the programming that goes into it involves a look-ahead process where it actually needs a little bit of time and look ahead to find the parts of the audio file that it can take out. So first things first, let's go back and listen to these various files. So the first one here, this is our lossless file. This is the WAV file. So this is pretty much like what we recorded into Bitwig and then just pulled down the sampling rate to 48K as opposed to whatever that crazy high number was we started with. Testing, one. How many times am I going to do that? Testing, 1, 2, 3. Testing, 1, 2, 3. Cool. 320 kbs. Testing, 1, 2, 3. 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 So that's pretty crazy, right? The difference between this 64 and the WAV file isn't that big of a difference. Let's listen to those two back to back, just out of curiosity. Turn you off. Testing, 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3. So there's definitely a difference, but it's not as great as the difference as what we had with those different wave sampling rates. So from the 48K to the 8,000K was a lot bigger a difference than what we just heard. And part of that is because the MP3 conversion works on a psychoacoustic phenomena known as auditory masking. We're not going to get into that right now, but you actually could look at this very closely and you'll see why it is MP3 compression can work and actually produce a very similar sounding result. The last thing I want to show you guys is that each of these files is still sampled at 48,000 kilohertz. So let's unsolo this and just zoom way in again, just for the sake of it, so you can believe me. I assume you guys do believe me, but for right now, just realize that this one isn't in time, so we have to look at these lower ones. And you can see same amount of dots across the screen. So the sampling rate has all stayed the same. What does this mean to us? Well, it means that sampling rate is very, very important with our music and the overall perceived quality of it. All right, it's more important to work with a higher sampling rate than it is to make like that compression stage later on. If you work with a very low sampling rate from the source, from the start, your audio quality is going to be potentially in danger at that very beginning stage. So let's kind of recap what we've gone over here. We've talked about sampling rate, which is referring to the number of points on an audio file over time. And we've talked about bit depth, and bit depth is the number of choices each of those samples has on this amplitude y-axis. It's really not that simple, but for our points, that's all we really need to think of it as. And one good example I've heard is that you can imagine sampling rate being like the number of pixels in a digital image. All right, but bit depth refers to the number of color choices each one of those pixels can choose from. So to have a super low bit depth is really stupid if you're using a really high sample rate. Likewise, having a very low bit depth or having a very high bit depth and a very low sampling rate isn't going to make a whole lot of sense. For our purposes, really working at 44.1 kilohertz per second and 16-bit for our bit depth should be fine in most applications, but we're going to go on and maybe talk a little bit more in a couple of future videos just exactly why that 44.1 number makes sense and doesn't sound weird to our ears, and also talk about this whole revolution to trying to push for 24-bit audio as compared to 16-bit audio. Right now, CDs can only work with 44.1 16-bit. That's how they're formatted, and you really can't break that. DVDs are a little bit more flexible, so you can actually put on different file types, not just 44.1 16-bit. But I don't really think we're going to talk about that really beyond what I've just mentioned there. If you're interested in looking into these concepts more, of course, do the research, and you can post comments on here letting us know what you were able to find out. And of course, you can experiment with different sampling rates as well if you wanted to. So let me just open up one more instance of Media Human. I've talked to you guys long enough about these concepts, but I encourage you to go out there and do your own experiments with different forms of compression to see what you can come up with. I did want to show you guys the file sizes as well of those MP3 files as compared to the WAV files. Of course, it's not going to look like huge differences because the file sizes are so small to begin with. But basically, with our MP3, if we go in here and go to custom, we have a whole host of choices. So we can actually change the sampling rate up or down if we chose to. The thing to remember though is once you take something like that 8 kilohertz wave file here, once we take this, and I'm just going to do this as an example, if we change this to an MP3, and let's say we choose to sample this out in mono at 8,000 hertz, for example, and we'll make the bit rate something like 64. Okay, this is like the lowest possible that we can get. You'll see where I'm going with this in a second, so just bear with me while I set this up. I'm getting super tired, so I'm not even really sure what I'm doing. We'll see what happens. So this is my 8K MP3. Now let's say I bring this in again. And this time I'm going to convert it to a WAV file, and I'm going to go crazy here. Let's make it mono, and let's bring the sample rate all the way up to 96K. And I make that conversion. Let's call it 8K2. Guess I could have been clever and called it 8K3, but oh well. And let's look at these guys real quickly. First of all, let's look at their file sizes relative to one another. So this first one here, the original, is 90 KB. The second one, the MP3, is going to be 49 KB, so almost half the value. And the third one here is going to be, let's see if it will load up for us without crashing everything. It'd be a real shame if everything crashed, having worked on this for so long and hopefully having taught you guys something. This last one has gone all the way up to 1.1 megabytes. Now, what you have to realize, and this is what I'm going to show you guys when we go in and play these files, this is the biggest file that we have, that we've created, I think, the whole way through. Maybe this WAV file is a little bit bigger, but let's go into Audacity again. Let's close these guys up one last time for posterity's sake. Let's bring these guys in. Okay. And the first one was... Okay, so here is our MP3 file. So let's move this track down. This was our original. This was the third one we created. And let's listen to the three of these. So here's the first one.
Testing, 1, 2, 3. Testing, 1, 2, 3.
Cool. Let's listen to the second one.
Testing, 1, 2, 3. Testing, 1, 2, 3.
And then we'll listen to the third one.
Testing, 1, 2, 3. Testing, 1, 2, 3.
One more time, the second one.
Testing, 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3. Testing, 1, 2, 3.
The point I'm trying to make is that you can't up-convert an audio file. So I'm going to look at these two guys here. Let's look at these. Zoom it in. And now what you're going to notice is that there are more samples, right? You will see more samples in this bottom example here. Let me get to a better point in the WAV file. Grab the size a little bit. There are more samples, but it's basically just going to be repeating a lot of samples multiple times. And you can kind of see that when I zoom out. You can see that this is just repeating the same value and then repeating this same value and then repeating this same value, repeating this same value, because it can't do more than what this version has done that we've used as the basis for our conversion to go up. So never think that because you get a 128 kilobyte MP3 file, that if you make the conversion to WAV, that the quality is actually getting any better. It's not getting any better. It's exactly the same, only it's a higher file type. The one case and instance where you will have to do that is if your digital audio workstation or an audio application you're using won't let you import an MP3, in which case you will have to up convert it to a WAV just so you can bring it into your digital audio workstation. So I hope a lot of this stuff has made sense to you guys. I always think it's a pretty fun thing to do and to show people so you can actually understand what sampling rate is and what bit depth is. And hopefully from these examples, you have been able to see that. So thank you guys so much for watching and stay tuned for another lesson.